Welcome to video 1 for this unit on exponents and scientific notation. In this video, we're going to focus on exponent rules. In expressions like 5 to the third power and 8 to the second power, the 3 and the 2 are called exponents. They tell you how many factors to multiply. The 5 and the 8 are called bases. They tell you what factor to multiply repeatedly. For example, 5 to the third power equals 5 times 5 times 5. The base tells you what factor to multiply, and the exponent tells you how many factors to multiply. Here is another example. 2 to the sixth power equals 2 times 2 times 2 times 2 times 2 times 2. One advantage to writing a base of 2 with an exponent of 6 is that we can see right away that this is 2 to the sixth power. When this is written out using multiplication, we need to count the number of factors. Imagine writing out 2 to the 100th power using multiplication. Now let's consider what happens when we multiply powers of 10. Let's multiply 10 to the fifth power and 10 to the second power. We know that 10 to the fifth power has 5 factors that are 10. And 10 to the second power has 2 factors that are 10. That means that 10 to the fifth power times 10 to the second power has 7 factors that are 10. 7 factors that are 10 can be written as 10 to the seventh power. In general, multiplying powers of 10 corresponds to adding the exponents together. This is one rule that makes it easier to understand and work with expressions that have exponents, since we don't have to write out every single term when multiplying powers of 10 together. Next, let's consider what happens when we take a power of 10 to another power. What happens when raising 10 to the fourth power to the power of 3? In this example, there are 3 groups of 4 factors that are 10. Which is equivalent to 12 factors that are 10. Or 10 to the 12th power. In general, taking a power of 10 and raising it to another power is the same as multiplying the exponents. But what happens when we divide powers of 10? Let's consider the problem 10 to the ninth power divided by 10 to the third power. Remember from earlier that when multiplying powers of 10, the exponents add together. So when dividing powers of 10, the exponent in the denominator is subtracted from the exponent in the numerator. This makes sense because 10 to the ninth power can be rewritten as 10 to the third power times 10 to the sixth power, since the exponents of 3 and 6 add up to 9. This can be rewritten as 10 to the third power divided by 10 to the third power multiplied by 10 to the 6th power. Since 10 to the 3rd power divided by 10 to the 3rd power is equivalent to 1, the quotient of 10 to the 9th power and 10 to the 3rd power is 10 to the 6th power. This gives us a new exponent rule. When dividing powers of 10, the exponent in the denominator is subtracted from the exponent in the numerator. So far, this rule only makes sense when n and m are positive exponents and n is greater than m. But we can extend this rule to include a new power of 10, 10 to the 0 power. If we look at 10 to the 6th power divided by 10 to the 0 power, using the exponent rule gives us 10 to the power of 6 minus 0, which is equal to 10 to the 6th power. So dividing 10 to the 6th power by 10 to the 0 power doesn't change its value. That means that if we want the rule to work when the exponent is 0, then it must be that 10 to the 0 power equals 1. Thank you for watching video 1 of 4 for this unit on exponents and scientific notation.